The human body is a complex and fascinating machine. It requires energy to function. This energy comes from the food we eat, but food in its original form is too complex for our bodies to use directly. That's where the digestive system comes in. Think of the digestive system as a disassembly line in reverse. It breaks down the food we eat into smaller and simpler components. These components, called nutrients, can then be absorbed into the bloodstream. Our cells use these nutrients as fuel. Without the digestive system, we wouldn't be able to extract the energy and building blocks we need from food. Imagine a world without the pleasure of tasting a juicy burger or a sweet strawberry. Without digestion, this wouldn't be possible. The journey of digestion begins in the mouth. As we chew, our teeth grind the food into smaller pieces. This process is called mechanical digestion. It increases the surface area of the food, making it easier for enzymes to do their work. Saliva, produced by the salivary glands, mixes with the food. Saliva contains an enzyme called amylase. Amylase starts breaking down carbohydrates like starches into simpler sugars. Our tongues help mix the food with saliva, forming a soft mass called a bolus. The tongue plays a crucial role in swallowing. It pushes the bolus to the back of the throat, initiating the next stage of the digestive journey. Have you ever noticed how difficult it is to swallow dry food? Saliva ensures the smooth passage of food down the esophagus. The esophagus is a muscular tube connecting the mouth to the stomach. Once the bolus is swallowed, it enters the esophagus. Muscles in the esophagus contract in a wave-like motion called peristalsis. Peristalsis propels the bolus downward. Think of peristalsis as squeezing a tube of toothpaste. The rhythmic contractions of the esophagus ensure that the food moves in the right direction, even against gravity. This is why we can swallow food or drinks even when standing on our heads. The bolus then reaches the lower esophageal sphincter, a ring-like muscle at the bottom of the esophagus. This sphincter relaxes to allow the bolus to enter the stomach. It then closes tightly to prevent food and stomach acid from backing up into the esophagus. The stomach is a muscular sac that churns the bolus and mixes it with gastric juices. These juices contain hydrochloric acid and enzymes that further break down proteins. The stomach also acts as a temporary storage tank, regulating the rate at which food enters the small intestine. After spending several hours in the stomach, the food is now a semi-liquid mixture called chyme. The chyme is gradually released into the small intestine. The small intestine is where most digestion and absorption of nutrients take place. The small intestine is lined with tiny finger-like projections called villi. These villi increase the surface area for absorption. Nutrients from the chyme pass through the walls of the small intestine and into the bloodstream. Whatever remains undigested in the small intestine moves into the large intestine. The large intestine absorbs water and electrolytes from the remaining material. This process solidifies the waste products, forming feces. The feces are then stored in the rectum and eventually eliminated from the body through the anus.